Hello everyone, are you able to hear me? Hi Veena, are you able to hear me clearly? Great, great. So everybody is able to hear me. Alright, so let's start for today's discussion. So I did receive some of your questions, and so before we start the discussion, do you have any questions for me? And also please note that I really apologize for what has happened in last week. So while I was relieving the old cloud labs, we were moving to the new cloud labs. I had deleted the no big data website. Okay. So we had to restore it to a 1 week old version of the website, which means we have lost your work of 1 week. Okay. We have lost all the changes for of 1 week. So I extremely apologize, and it was a big blunder on my part. All right. So so that's about it. So first we would like to go. So Veena's question is, input data is split and stored in HDFS. How about output? Okay. So my answer is any data that gets stored in HDFS is split into block. Okay. So both and both input and output of MapReduce job is stored in HDFS, which means whether it's input, output, or whatever it is, if it's stored in HDFS, it is split into blocks. All right. And it's not about MapReduce. That's the behavior of HDFS. Even if you don't want to use the data again, then also it will be it will be split into the blocks. All right, no matter what. Does that answer your question, Veena? All right. So in the last session, we discussed about MapReduce semantics. Today, we are going to start real work with a library called Hadoop streaming. Hadoop streaming is basically a wrapper around the native Java MapReduce. Okay, so when MapReduce was first written, it was written so that only Java programmers could work on it. Okay, but later on, some of the Java programmers and C programmers, the two kind of programmers, later on some people realized that lots of work is not there. I mean, a lot of people have already written their programs in various languages, so somebody wrote a wrapper which made it possible to run any process from any process as map and reduce. All right. So the way uh, those who have used C code or Java code, they know how to run a system command, right? So when you run a system command, you can execute any program from either C code or Java code. So Hadoop streaming is essentially executing an external binary from this Java code. So somebody wrote this nice layer called Hadoop streaming jar, Hadoop streaming library, which makes it possible to run any program as map and reduce. Okay, so we will be using it first, and then we will get into Java. So why I'm talking about streaming, Hadoop streaming library before Java, so that there are many people in this class who are not very well conversant with Java, but are conversant with one programming language or another. All right, and already we have talked about something called pipelining of the commands, right? Therefore, it will become extremely simplified, and the I mean, in my honest opinion, before starting to write MapReduce in Java, you should always try to get your work done through Hadoop streaming job. All right. And as a matter of fact, when I was writing my recommendation engine, the first phase of cleaning the data, all of that I had written using streaming. Okay, I wrote in Python and using streaming, and even though I was fairly new to Python, still I found it far more easier to write in Python and run it through Hadoop streaming rather than writing in Java and getting it executed like a proper MapReduce jar. Okay, so that's an interesting phenomena, and thinking about it, since my learning has been really quick, so thinking about all the aspects, I've given it a thought, and we have realized that running the Hadoop streaming before the Java MapReduce makes more sense. So let's jump in. Okay, so we will try to write a MapReduce code in using our normal shell commands. Okay, so I don't want to scare you with the other reason is that in case I show you lot of code, most of you, even if you are from programming background, you will get scared of the um, of creating a MapReduce code. So Ravi, I'll discuss the assignment after the streaming. All right, that way it'll make more sense to you. Good. All right. Now, so streaming job, Hadoop streaming job, or MapReduce streaming is the same thing. And the difference is, and also, let's first disambiguate the word called streaming. Okay. Streaming also means video streaming. Okay. Just like YouTube. Streaming also means stream processing, meaning, meaning, what do you call, handling fast paced data by converting it into bigger chunks. Okay, that we will study streaming in later in the ninth session. Okay, now the next one is your so Hadoop streaming, and then we have, all right, the other is streaming, as in streaming the data through a process. Okay, so maybe like running filters in Unix. You remember our discussion? I hope I had discussed the filters earlier. Did we discuss the various chaining of various commands in Unix? Have we discussed that earlier? Great, great. So how many of you were able to chain the command and run it? Wow. Ravi has done, Saryu has done, Sridhar has done. Alright. Who else? Good. Please raise your hand. Brilliant. Alright. Great. So that's called, these are the various definition. And here when we say streaming, we mean the last one. Streaming the data through a process as if the way we do it in the filters in the Unix. Okay. So good. So here we go. So in this example, what exactly are we doing? So we will be writing two programs. One is mapper, other is reducer. And these mapper or reducer could be any binary. It could be your custom program. It could be written in Python. It could be a binary for which you have no source code. Okay. So the only condition is the mapper command, whatever it is, it has to give out key and value tab separated in a line. Okay, so mapper has to give out one key value per line, although it may give many key value or it may choose not to give any key value. The necessary condition is the key value pair has to be separated by new line, and key and value have to be separated by tab. So pair has to be separated by new line, and key and value by default has to be separated by tab. And the way reducer will get the data instead of grouping. Reducer will only get the data in the sorted manner. Okay. Now you must be wondering that I told you earlier that reducer will get the data grouped by, but that's a design choice which streaming people did. Okay, they ungrouped the data and kept it just the sorted one. That is something as part of the design, so that it is easy to apply various kinds of filters from the command line. Okay, you will see this as we talk about. So now that makes Hadoop just a sorting library. The output of mapper, which is given as key tab value, get ordered and given to the reducer. That's all Hadoop will do in this case. Now let's take a look at this command. Okay, so let me paste it here. So you notice that it's Hadoop jar followed by this new library. This is the code which has its own internal custom map reduce code. Inside this code, what it does is it executes these arguments as mapper and reducer, because any Java code can execute any external program, right? So this is the library, this is the Java code somebody wrote for us. The Apache Spark team, Apache Hadoop team wrote for us so that we can use any command as mapper and reducer. So you provide your input data like this. This could be a file or a folder, and you can specify a file in absolute way, starting with the slash, or in the relative way, relative to your home directory in HDFS. Both of these have to be in HDFS. So this is the way you can specify your input and output. Again, the output folder should not exist. Now this is the real work. All right, so this is my command which will act like a mapper. Now you would be wondering, where is the key and where is the value? All right, let's take out this particular command and understand what does this command do exactly. What does this command do exactly? Okay, so I'm trying to log in onto somewhere. All right, or should we log in into the browser? I think we should just log in into the browser. Yes, so the input file and output file both have to be in the HDFS. I mean, both will be in the HDFS. All right, let me try to launch it from my console. That becomes easier for me. All right, so SSH. This is okay at say h2.cloudxlab.com. Let me just try h1. Yeah, I've logged in into h1. All right, so we will be experimenting here in this one. All right, so here is my command. So let's understand, what does this command do? What does this command do? Anybody quickly? Yeah, it is SED substitute space with new line. All right, let's see whether this command is working or not. When I say echo Sandeep Giri, you see, we get this. In case we say SED like this, in case we say SED like this, let me remove the single quotes. You can see that what it has done. What it has done is converted it into Sandeep and Giri in two lines. Okay, so space has been substituted with the new line. That's what it does. It replaced space with new line. Slash n means new line. So SED is saying substitute space with new line and do it globally. And that's what it did. Okay. So if I say I am Sandeep Giri, it'll convert it into I new line, am new line, Sandeep new line, Giri. Perfect. Now we go ahead. Now what does this reducer do? Okay, reducer is the other command. So that this was our command for the mapper. All it's doing is replacing spaces with the new line, which means each line has a key, but there is no tab and there is no value. As I told you earlier, key, tab, value. Now if you don't provide a tab and you don't provide a value, that means value will be considered null, and everything in that line will be considered as the key. So there is no value, only the key. So Hadoop will basically sort it. All right. Now let's understand, what does the other command do? This command basically computes the frequency if the input is ordered. Let's try to feed it A new line, B new line, C. All right. Okay. No, this is not working. I'm saying a, echo A, echo A, echo B, and echoes A. See that? Now, if I say one more echo A, this is what we get output A, B, A. Alright? If I group it together and pass it to somebody like WC, it'll count the words, count total number count, but it will not do it in per frequency basis. Now you can see that unique minus C has counted the second two, these A as 2, but it has not counted the first A. Alright, so which means the unique command only works if the data is sorted. If I sort this data, that means my input has become A, and then B. Okay, so whatever was the output of echoes, I have piped it. This is my pipe. I have piped it to sort command, and then this is what we get. Alright, are you with me? And after sorting, now we can pass it to unique minus C. And now this time, after the data has been sorted, unique has done a good job of counting the unique values in this input. Okay? Now, so we have two commands. One is unique, which is a reducer, and other is SED, which is the mapper. Yes, somebody has raised a hand. Yes, Sridhar. Something urgent in which I can help you? Alright. So again, this command what it's going to do is it's going to take this input file. Alright. Now it's going to take whatever input we have, and this is exactly what it's going to do. This sort command is the role of Hadoop. The sort command is the role of Hadoop. This is your mapper who is giving out the key and value. Value may be null, okay? And sort is just doing a sorting of the data and then unique. Make sense to all of you? You can see that it has converted the input into proper word count. Now let's try to execute this command first, and then we will see whether it runs correctly or not. Again, the data is in MapReduce. Let's try to modify some of the things here. So this is input is correct, right? Data, MR, word count input. Please check in hues. Now I will just put it in my current folder and I'll just give it a name called Unix. Alright, should I run it? Now also note that when we run a command in Unix, either it has to be in the same line or you can place a new line, this slash forward slash like this at the end of line. Okay, now let's take a look. It says the user lib MapReduce, Hadoop MapReduce is not a valid library. That's correct because our library is in user lib HDP. What was that? User HDP. Yeah, current, 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 and then Hadoop MapReduce. What was the command which we used yesterday? If we are not able to find it, what we can do is we can just use the find command. We can say find slash minus name and then say Hadoop streaming asterisk because there might be a version in it and send all the error to dev null. So now you can see that it has found our library here. Great. All right, let's try to do that. All right, let's see if it runs or not. Okay, you can see that it's submitting the job. All right, and you can see the progress that is doing something. Now it has finally finished the work and stored the data in this directory. Let me check if it has done something by using Hadoop fs-ls. You see that? Now it has created this file called part. Do you want to have a look at what exactly is going on there? So I'll say minus cat, and then I can put a pipe and say more. I'm putting more because otherwise there'll be I'll have screen flooding. Lot of You can see that it has done a good job of counting the words. Do you find something bad? Do you have suggestions for it? What all should be improved in this program? Okay. So now you just saw that we did not have to write any program. We just used our usual commands to get the work done on Hadoop. So in this output, do you think something could be improved? Something could be made better? Sushant says, yeah, remove double quotes. Okay, we will remove double quotes. And Ganpati says remove double quotes. Sushant says duplicates. All right, these look like duplicates, but they are different words. You can see double quote God and then double quote God, double quote God, single quote S. Yes, that's correct, Ganpati. We can remove special characters. Remove. Okay, great, brilliant. So, all right. So, can anybody suggest me what could be done? Anybody? How can we remove these special characters? Yes, Veena? You have a question, Veena? All right. Was it related to maximizing the screen? This one. Now, is that all right? Great. All right. So, good. Now, all right. We have few more questions to answer to. Veena's question was, is it one mapper, one reducer? We will come back to that again. Okay. We'll come back to that again after some time. And now there is a question from Veena. What sorting does Hadoop do internally? They have created their own sorting algorithm. It's basically a variant of external sorting, what we had discussed earlier. Okay. Now there's another question from, why did we change the logic of mapper and reducer in this case? We did not change the mapper or logic at all. We we basically created a mapper. There was no mapper. So we created a mapper. This is the mapper. And this is my reducer. Okay. What change are we talking about, Sushant? I'm in the terminal, Ganpati. Also, on the top of the page, I would like to put something. My to-dos. Okay, there are always some to-dos at the end of session, and I always miss out those. One to-do is enable SSH into the account on H2 and H3. Right now, not many people are able to use SSH directly, but browser one is running. All right. So Again, Sushant's question is, how is it pertaining to streaming? All right, we are talking about the third use case, not the second use case. Okay, we this streaming, the keyword means here, the streaming means streaming your data through any command. That's what Hadoop streaming means. Streaming means passing your data through any command is called streaming. Okay, that's one of the big confusing words you will encounter. So here we are talking about passing your data through a command, and that's what we did, right? Now, Randir's question is Hadoop streaming used specifying Unix command? Yes, and also for any other executable. If you can run the program, if you can run a program on a terminal, on a Linux machine or a Windows machine, or on the machine on which the worker is installed, you can run it as a mapper or reducer. All right. Streaming is slow. That's Naveen's point. Hadoop is only sorting the data. Yes. Streaming is slightly slow, but since it's a distributed computing and there are lots of computers in the network, so that slowness is actually overcome by having more nodes. And the kind of jobs which we execute, okay? Now, what does Hadoop streaming.jar has? Hadoop streaming.jar has code which basically make your program run inside the internally MapReduce job. So Hadoop streaming has a mapper and a reducer internally, which takes the argument and run them inside their code. All right. You will understand it when we talk about more about Java MapReduce. So Sridhar's question is, where is user lib in UI? It is not. It is not. Okay. User lib, as I told you earlier, this jar has to be in the local directory, and that's what it is. Okay. But when you say ls this, you will find it. Okay. Not this, but where is my command? Where is my command? All right. This is the command we are talking about. It's not possible to fit everything into a single line. Never mind. Yeah, this is better. Right? Now you can see that although it's going a little overboard, let me just change its font, the font of the whole thing into 30, 33. All right. So here, what exactly is going on again? Let me take a step back. Your command, your SET command, and this unique command is being executed by Hadoop, not only one node, but they will be executed on many nodes. All right, Shushant. So, and this is being made possible by this Hadoop streaming.jar. Hadoop is basically running this Hadoop streaming on all the nodes, and this Hadoop streaming internally is executing your mapper and reducer on all the nodes on chunks of the file, and that's what is happening. Make sense to you now? Where do you get this? You basically this is, we found it in the local file system. Okay, it is in the, it comes with, it comes with Hadoop client. When you install Hadoop client, it is installed and you can find it. You can use a command like find slash minus name Hadoop streaming dot jar. Okay, this is how you can find it in the local file system. So do we need to have Hadoop streaming dot jar for every program? Hello. So there's a question from Shushant. Hi, are you able to hear me? All right. All right. I'm so sorry. The network is fluctuating here. Just now power went off and it came back. So probably we'll be able to resolve it by tonight. All right. Are you able to hear me now? Hello. Hello. Yes. Are you able to hear me now? Hello. All right. Finally, I'm able to see your comments. Extremely sorry and extremely disappointed with this connectivity thing. Okay. Having two connections and a complete power backup doesn't solve the network disconnectivities. All right. Extremely sorry for this inconvenience. All right. I was talking about a question from I was talking about a question from Sushant. All right, that's when the this thing broke. All right, so here is the question. Okay, so this is a question from Sushant. So do we need to have Hadoop streaming.jar for every program? Of course not, because Hadoop streaming.jar you did not change, you just executed it. Meaning, if we are writing mapper and reducer in Java, do we need to put this Hadoop? No. If you are writing MapReduce in Java, you will be using your jar, not Hadoop streaming.jar. Okay, you will be creating an alternative to Hadoop streaming.jar. All right. So somebody wrote Hadoop streaming .jar, which is standard map reduce, which is internally calling your commands for mapper and reducer. It is as simple as that. Okay. It is just like system commands. If you are aware about system commands, all right. Does it make sense, Sushant, to you? Great. Now moving on. So we are able to run this command as mapper and reducer. Now this is what went on behind the screens when we were running this command. Yes, it is like support for any binary. All right. Now this is what is happening in the background. Imagine there is one line called Sare Saga, and you replace this line with a new line called substitute space new line. Now let's just make it little more. Okay, we'll just finish one loop and then change some data and then see what is going on. Okay, so your mapper is run first. So this is your input data. Wherever on your cluster there is this input data, for every line your sed command is going to be executed. For every block of code, sed command is going to be block of input, it's going to get executed. Sed command is going to get executed, and what will sed do? Sed will replace space with a new line like this. All right, and once it has replaced space with a new line, it will it will feed this to Hadoop. Okay. All right. Let me take a step back. Hadoop is actually doing the whole magic. You handed over four things to Hadoop. You gave four things to Hadoop. One is input, output, your mapper, and your reducer. okay, along with this Hadoop streaming your .jar. Okay, now Hadoop takes your mapper, runs it near the data. Okay, for each record in the input, for each record in the input, it is going to execute your mapper, and that would result in one word per line, and this dashed line represents what is Hadoop going to do with these results next. It's going to sort it, it's going to order it sequentially. You can see that Ga has come before Re and Sa. After that, it will execute your reducer in this data. And as I showed you earlier, when you execute unique minus C on sorted data, only then it gives you proper output. Okay, and this is what we get. Make sense to everybody? Yes. So Sridhar is saying, what if file is so big? If file is so big, it will run on many more, many, what do you call? There will be many such phases happening parallelly. All right. There will be many such phases happening parallelly on many nodes. All right. So I'll show you. So this is how it will look like. Let's say there are two nodes in your cluster like this. All right. I'm not sure if you can see it. All right. You can see that. Similarly, these things are going to happen parallelly on all of your nodes. So if there is another node containing, say, ga, okay, then it is going to convert that into and ga, and then this also will get taken by Hadoop, sorted and merged here, and then will be given to the unique command. All right, this is what is going to happen. All right, so I think I'll just show you the next screen that will answer most of your questions. All right, so this is what it is. All right, so basically it's going to execute your SED command near to the data. Okay, it's going to execute your SED command very close to the data, so that you do not have to carry the data before being fed to the mapper. All right. There's John. Feel free to ask those questions here. I'll like to answer those. Those are very nice questions. I had look at it, but did not get time to reply. So feel free to ask these questions here. Probably most of us will be having those doubts. All right. Now next question is, if there are multiple files in the input folder, does the mapper execute all the file on all the files? Yes. Okay, so when you have many files in a single folder and you're providing a folder here, it will concatenate all the data and then run the mapper and reducer. All right, here we go. Now what if we have multiple reducers? What if we have multiple reducers? Then it will distribute the keys to the multiple machines, and it will run unique commands parallelly on those machines. But it will make sure that one key, say for example sa, will not go to multiple machine. It will always go to one machine, one reducer. It will not be divided. Okay, that is a very important aspect of MapReduce. Yes. All right. So Vina's question is, in this case, key is equals to unique word and the value is number of times the word is repeated. Yes, that is right. That's the output of our program. Now what if you have a bigger command? Instead of a single command, if you want to have a bigger command, let's say for example, whatever you have suggested earlier. Let's say we want to remove the special characters. Second, we want to convert the upper caps into lower caps. So this command you see here, it says anything which is non-alphanumeric, replace it with nothing, meaning delete non-alphanumeric the from the line. Second command says that convert the capitals into lowercase. Let's try to run this and check if it really works or not. Alright, let's try to run it without Hadoop first and then we will run it with the Hadoop. Okay, so you see this command, what it does is it will take what, let's say we are passing a dash b dash c and then s and 09 and then we are saying at. This is our input. When we pass it, it converts it into something like this. It says a b c and s09. It has removed everything else. All right, that's what we wanted, right? Now let's use this chain of command as our mapper. All right, to do this we will first have to create a file. Let's say mycmd.sh. We are creating this file. Okay, also please note that I'm creating it in the local folder and then you can say nano is an editor and mycmd.sh and we write everything into it. Okay, you can see that. Also please note that once we have saved it, we have to make it executable. And how do you make it executable? By changing the mode to +x of that command. Okay, and this is a very common mistake which we all do. Once we change this cmd to this one, then we will be able to execute it like this. All right, so we are able to execute it in this manner. Now let's test it whether it's working fine or not. A1 hash B and let's say %D. Okay, you can see that it has cleaned the data. It has removed special characters like hash and ampersand and converting it into lowercase and also replaced the space with the new line. All right, good. So now let's have a look at what goes on here. So now since we have created a command called mycmd.sh which will not be existing on any other node. We just created this file called mycmd.sh. It may not be existing on all the nodes, right? It may not be existing on all the nodes. So you can see it's only existing in my folder here. So we will have to ship it. And how do you ship it? By saying minus file mycmd.sh. Okay, so therefore what does it imply? We can execute any program or whether it's installed or not on all the machines. In case we can install it by just copying it, then we can execute it. All right. Now let me just take this part and put it here like this. All right. All right. Is everyone with me till here? Let's try to execute it. Though please note that the reducer remains same. Reducer remains same, input folder is same. One more thing is here. We are saying let's have multiple reducers. Okay, let's have multiple reducers. We will talk about this at later point of time. So we increased few things this time. We increased one more input called please copy this file to the central place. And how does Hadoop do it? Hadoop has something called distributed cache. And what does distributed cache has? Whenever you want to schedule your execution of things on the cluster, you can take some data along with it on every node. So you can, before launching the program, you can push the data to all the nodes, and when the program gets executed, the data will be available there. And that's how it happens. So before our mapper is being executed, our command called mycmd.sh is being executed. This file mycmd.sh is being copied on all the nodes. All right. That also means that in case you have some legacy code in your organization that you want to execute as mapper, you can simply ship it by using -file command. All right. Now, second is if you want two reducers. When do we use two reducers? So till now we were having only one reducer. Sometimes our reducer phase, meaning the phase in which we handle the output of the Hadoop sorting or the grouping. So we want to make that efficient. Sometimes your reducer phase might be very heavy, as in you are doing a lot of processing of the groups of the key and the grouped values. If you are doing that, then you need to have multiple reduce phases. But okay, so we are saying like this. You can have something of this sort. Let's try to. I'm putting backslash at the end, forward slash at the end of the line, so that it is considered as a single command. Okay. So it, what does it say? It says that the input path does not exist. Okay. We have, let's put it like this. It is in data, mr, word count, this, and output. Let's create for ourselves as Giri, then my cmd out. Okay, Randhir, does that answer your question? This is how we use multiple reducers here. Alright, now you can see that it has executed and the output is saved in this folder. All right, so this part you can let's have a close look at this. Okay, or we can open in the browser. We can open in the browser, and what we can do here, h1.cloudxlab, not here, this one, and I can say this. All right. Now you can see here, go to Asgiri. Was it coming or what has happened? Oh, thank you, Randhir. Yeah, username is not ours. Let me try to get out. Thank you so much. Session is being recorded, no worries. I just checked. John, to me it shows that the session is being recorded. It doesn't show for you? All right. Let's go to my folder here. Do you see my cmd.out? It has now notice this. Now we have two parts, part 000 and part 001. Okay. And inside part, let's have a look at what are the initial words. So some of the words for the word count went to the first node, some of the words went to the another node. Okay, and now you can see that the initial words that have gone here look like this. All right, they look like this. These are the initial words. So this is the word and this is the count. Okay, this is the word and this is the count. You can see that. Now let's have a look at what is going on here. What is in the second file? All right, let's have a look at this. Okay, now let's have a look at this. Now, as opposed to your assumption that it will go sequentially, so 005 went to the first node, while 00 went to the second node, 01 went to the first node, 02 went to the second node. So, as after sorting, it tries to equally distribute the key the way we divide the cards during poker game. When we the way we divide it is in the round robin fashion. In the same way, it has divided the keys between the two reducers. All right. So that is an important aspect, and we will cover it when we talk about partitioner. Okay. Now here again, Veena's question was, where are we mentioning reduce tasks? This is the argument. In the command which we had executed, this is where we mentioned it. All right. Now going back to your questions. All right. So Sridhar's question is, can you show one example how data will be partitioned between the nodes. Was this example which we run through sufficient for you? Because that will not be possible. You can only infer it by looking at the output here. Also, by going to this particular URL to track. Okay, let me make some notes, more notes. Fix IP problems. Right now we are running on internal IPs. We need to change that. All right. So John's questions, I'm making a note here so that we can talk about it again. Okay. So Sridhar's question is Sa Re Sa Ga with two nodes, as in Sa and Sa to one and Re Ga to another. Okay, okay. That's what we have actually done. All right. So Veena, the command line is clear to you now. All right. Will there be duplicates in the output files? Okay. Will there be duplicates in the output file? Can somebody tell? Of course not. Why? Because once the data is sorted and when we run the unique command, there cannot be the duplicates. One key cannot go to two files or two reducer. A key and all its values will always go to a single reducer, no matter what. That is a promise to you from Hadoop. Like saying, when you group by in SQL, all the values for that key will pass through the same aggregation function. It will not happen that only few values come in count. Okay? When you're saying select x comma count star and group by x, all the values for x will always be in the count. Right? It won't happen that only some of it came. Similarly, Hadoop says that all the values for a key will always go to a single reducer. Okay. So right now, there's a question from Sridhar. Right now we were partitioning. I mean, internally Hadoop is partitioning. It's sending first key to one node, second key to second node, then third key to first node, fourth key to second node, and fifth key to first node, and so on. That's what is happening. Have you mentioned 5 as reducer? Then what would happen is there'll be 5 files because there'll be 5 nodes running your reducer and parallelly writing to HDFS. Okay, they all be parallelly writing to the HDFS. Okay, so this is called partitioning. We did the partitioning by mentioning Hadoop was using internal partitioning. Internal partitioning technique is based on the hash code. Hash code is a technique by of converting a string of characters into a small integer, a small number. Okay, so right now it's generating an internal hash code, and based on that, it is partitioning. We can customize it. We can say, no, 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 that's not the uh, correct hash code. Here is my correct hash code, and that Hadoop will honor. Now, what is the advantages of many reducer? Of course, it is faster. It's doing the processing on multiple nodes. Okay. Now that was our exercise. Now there are a few more questions. These are very nice questions and very important questions. After that, we can take up John's questions. So here is Bala's question. Do we have a function to replace a particular character in the words example, replacing quotes with spaces while sorting? This is done as part of this is done by your mapper program. Okay? And that's what we have done here. That's what we have done here. If you look at our code here, if you look at this line here, this line, what exactly are we doing? After we have replaced, first line is first replace space with new line. This is what it does. Substituted spaces with new line. Second, this guy has removed anything which is non-alphanumeric. And then this guy in the, so it's a pipeline. There are, whatever is the output of this first command, okay, whatever is the output of this first command. All right, let me just change their colors. That may make some difference. That may make some difference. Yeah, so these are the three different commands which are being chained together, and each one is doing something. All right, did you get your answer, Bala? Okay, now, is partitioning done internally when we specify multiple reducers? Yes. This is done internally by Hadoop, but we can customize it. Customize it. We can explicitly say, take this key, send it to the first reducer. Take this key, send it to the second reducer, and so on. Okay? We can specifically say, okay, this key, send it to first, say this key, send it to second, and so on. First one goes to the first node, second one goes to the second node, third one goes to the first node. Alright, now this is not completely true. I just gave you an example. Okay, I just gave you an example of how a uniform partitioner works. Okay, how a uniform partitioner works. So the way actually it works is, whatever, say this is the string, it is going to convert it into 0 or 1 if you have two reducers. Okay, so any key will get converted into 0 or 1. Okay, if you have three reducers, okay, key will get converted into 0 or 1 or 2. All right, just give me a second. Sorry for interruption. Yeah, I muted it. Okay, so all right, Suresh, did you get the answer? Now, there's another question from Randhir. Who will take care of moving the same key value from different mapper? Will it cause network issue if we have large data? Yes. Okay. Yes. We will have, if we have large data, we will have lot of movement of the keys from one node to another. All right. Okay, Sushant's question is, so if multiple reducers make process faster, actually this was the half of the story. Multiple reducers do make process faster, just that there is a lot shuffling required because the data has to be sent to two different nodes. Now, further question is, will multiple mappers will do any good? Yes, of course. Multiple mappers are already there. It's based on number of nodes, number of blocks which are there in the input data. Based on that, there will be that many mappers. Okay, coming back to it. All right, all right. So this is pretty much. So let me first. There are a few more questions which are yet to be answered. Let me finish those. We will come back to this how many mappers and how many reducers again. There is a full page which we want to discuss about. Here is something. Yeah. All right. So if people can help me answering this, it'll be great. Okay. So first question to all of you: does application master run within a container? Anybody? Anybody? Let me open that diagram. If you don't remember, I'll help you. All right. Um, this was the one. Yep. All right. Here, actually, I have added one more slide to assist you. Okay, here. Does the application master run within the container? This guy, does it run inside a container? Yes. Container is the way node manager or resource manager execute anything. Container is the boundary in which any process can run. Okay, so you can see that a client started the resource manager, then started a container. This application process is application master. Here application master can clone or can ask for another container. Okay, so this application master is also running inside a container, and then once application master boots up, it asks resource manager to get more containers for the subtasks. Okay, so yes, very good question. All right, now you can see what are the containers in this context. Are they same as Linux container in Docker? No. All right, they are not the Linux container in Docker. They are Java processes. Okay, it's a kind of a well protected environment, and most likely I have not studied the source code. It's going to be, if you are more inclined, if I have to do the same thing myself, what will I do is I will extend class loader. Okay, because last time when I wrote the plugin manager, in which I had to isolate a process from intervening the other resources, I had to write my own class loader in Java. And in class loader in Java is a basic way of making two programs not interfere with each other. If you have been from Java background, then you would be knowing something called Tomcat. Tomcat runs many web applications written in Java, and these web applications do not interfere with each other. In the similar way, these are Java processes or Java containers. Okay, and container is a generic term. It's like saying a box. Good, brilliant questions. When you explained application lifespan, did you mean life of application master container? Yes, kind of. So from here, the client is asks for resources. Client asks for resources, ask resource manager for resources first for a container, then creates a application master in that container. Then application master asks resource manager for more resources or more containers, and then creates the, say, if it's a map reduce, this will be your job tracker, and this will be your task tracker under here. And once that is done, if all of the map reduce process is finished, then it will tell resource manager to destroy, and then it will shut down. On completion, this will shut down. All right. So application master's container is just one part, the lifespan, because so first client starts the process, then does something, and then once everything is finished, then it will return to the client the results. Okay. All right. Does the what is the difference between a split and a block? Okay, can anybody explain? Although we will go into the details again, you will understand it. So block is a terminology. Block is in HDFS, while split is created by every map reduce MR job on top of block. Okay, so this is a biggest difference. Okay, so split makes sense. Split as a data makes sense, but block is not useful as a data, because block might be incomplete data. Block might not be having the boundaries, because half of the boundary is ruthless. It's just on 128 MB. Split contains records, the complete records. Okay, while block is like the physical bytes. We will go into the details when we customize a block. Okay, when we customize the split. Yes, blocks minimum usage. Not really. So block size is 128 MB, right? By default. But that does not mean if a file is less than if a file is less than 128 MB, then it will still have it will still have 128 MB reserved. Okay, this is no. It will not have it will not have 128 MB reserved. Okay, if that is what you meant. All right. So Pawan's question is, so there will be mapper splits and reducer splits. Okay. No. Actually, reducer will basically mapper splits. What we say is, when our mapper programs start executing, it needs data. Hadoop, if just feeds the blocks to our mapper program, it will not make sense. Hadoop first reads this raw data in the form of blocks and convert it into records, right? And what is a record in our case in the word count? Each record was a single line. A line means a record. All right. John's question is, so a split can span across multiple blocks. True. Okay, and while converting or creating splits, it's a little more involved process because it might read from other blocks as well, some part of it. Yes, maybe. Okay, here's a question from Ganpati. I have two files, one is of 100 MB and other is of 10 MB. Will it be stored in one blocks or two blocks? So file 1 in one block, okay, and file 2 in another block. Okay, we will discuss it later. Okay. All right, so I hope that answers everybody's questions. All right. Yeah. All right. So we will discuss it later. All right. So great. Again, there was a minor fluctuation, and my stuff is again not working. Are you able to hear me now? All right. Now, with respect to 5 and 6, let me try to answer 5 and 6. Sorting is the default property of Hadoop. What if my reduce program didn't need sorting? Why waste computation on that? You can turn it off. Turn it off. Okay? I'll show you how. All right. So here there are a few things which that's what I'm going to discuss. So here it's okay to have no reducers sometimes. Okay, sometimes you don't want reducers, you don't want aggregations. In those cases you can simply skip that argument called dash reducer. You can only have mapper. In these cases what would happen is there will be no reducer phase, and whatever is the output of the mapper, it goes into the HDFS. And you may ask that what's the point of such a program? There would be some programs. Let's say you are just trying to translate one data form into another without any aggregation, sorting, or any other functionality. Let's say you are zipping the input files and you're keeping a zipped file only. In those cases, a mapper called ZZ would be good enough for you. Okay, you could use a mapper called zzip and take the data from input and put it in the output, and that should be good enough for you. So in case there is no reducer, there won't be, and you don't want any sorting as well, then you can turn it off. You can turn it off by saying minus d map reduce of task equals to 0. So there will be no reducer at all. Nothing will happen. Okay, and number of mappers will decide the number of output files. If there are 5 mappers, as in 5 data blocks, and there are 5 mappers running parallelly, there will be 5 output file in HDFS. Now sometimes you may want more mappers. That is too configurable by saying conf.set number of map tasks and put the number. But by default, number of mappers is decided by the number of input splits, or generally, since number input split is generally of equivalent size like block, so number of input splits are generally equal to the number of data blocks. Okay, so number of blocks, and number of blocks govern the number of maps by default. If you have got 5 if you have got how much, 128 into 5, 1024. Let's say you have a file of 1024 size. Okay, how many are there? 1024 is 8 times, right? Yeah. So there are 8 blocks, so there will be 8 map tasks running parallelly on all those blocks, converting them into the key value pairs, which is being consumed by a reducer, and output is being stored in the HDFS. All right, so that was the answer for his question. Good. How many mapper instances are created? Each data node gets n into m mapper instance for n splits with m records. Yeah. So if you have n splits, there will be total mapper tasks. Mapper processes will be n, and your map function is going to get executed on each record. All right. So you are right. All right, so when I say number of mappers, it means number of map tasks, as in, so on each input split, or just for simplicity's sake, you can say that for each block of data, an instance of your mapper function is created, and mapper class is created, and every record in this block, or in this input split, will be passed through your map function. All right. So you can turn off the short by using by saying this. Okay, you can say minus d 0. Okay, there are two things we talked. One is command without having dash dash reducer. There is no dash dash reducer in this command. There is only dash dash, dash mapper. There is no dash reducer. Do you see that? So there are two things we did. One is run it without reducer. Other is explicitly turn off the sorting. Okay. All right, so we will talk about number of reducers and the problems after the break. Let's take a break of 15 minutes. Let me see if I can get a, there are a few more things I need to get done. Okay, break of 15 minutes, back by 10, 20, 23 p.m. IST. Okay, so it's a break of 15 minutes. We'll be back by 10:23. Okay, bye. All right. So, all right. So, can we start now? If all records in a split are run by the same mapper objects map, no, there won't be any problem. Okay. All right. So I'm trying to answer John's question. It's a very valid question. So you can always imagine that inside the inside Hadoop, this is what would be happening. Okay. Okay. I'm just being a little Java oriented here, so don't mind. Inside the Hadoop, before the process starts, this is what would be happening. Okay. So like this. Okay. For record, or let me just try to write a pseudo kind of code for each record in my split. Okay, for each record in my split. Okay, for each record in the split, it'll be calling mapper dot map, and then it'll pass the record. Okay, now question to you is, why would there be a reference problem? Okay, let's when we look at the Java code, we will talk about it again. Okay, all right, John. John, are you able to hear me? Bala is able to hear me. All right, great. Now, all right, so he is able to hear. All right, so there are one more thing which we want to discuss before the break. Yeah, that is number of reducers. Okay, number of reducers as in how to compute how many reducers do we want. Okay, how many nodes do you want to run the reduce tasks? All right, so the clever way is to basically find it out by experimentation, but it's always good to have safe starting point. So the first and foremost thing you need to do is find out how many maximum tasks can your cluster execute parallelly. Just a second. Hi guys. I'm really sorry to interrupt the class. My baby has fell down, so I'll have to take him to the emergency. Bye bye. Take care. I'm extremely sorry for this. Extremely sorry for this interruption. Bye.